Hello and welcome to my SUSECON talk about creating RKE2 cluster templates with Rancher. My name is Bastian Hofmann and I'm a field engineer at SUSE. My main focus are all of our container and Kubernetes related technologies such as Rancher, New Vector, Harvester and so on. If you're listening to this talk, it's probably no surprise to you that Kubernetes clusters are great and a great way to standardize running, monitoring and managing your application inside of containers. And if you have one or two Kubernetes clusters, it's great. You can pick the Kubernetes distribution of your choice, you can install it and start using it. No problem. But if then Kubernetes becomes more and more used in your organization, oftentimes in Kubernetes environment does not look like this anymore, but it turns out you are actually running not one or two, but multiple Kubernetes clusters. Maybe because you have different deployment stages, production, development, staging, QA, test. Maybe you have different environments because of different development teams and everyone wants to have their own cluster to not negatively influence another team if they destroy it. Maybe you have multiple data centers. Maybe you are running some workloads on-premise in a secure environment, some workloads in the cloud, or maybe you're also running Kubernetes at the edge on IoT and industry PC devices. And that means when you're managing these not only one or two Kubernetes clusters, but 10, 12, dozens, hundreds, thousands, millions of Kubernetes clusters, it can become quite challenging to keep them all in sync and to manage all the Kubernetes versions, to keep policies and configurations according to the standards you want. And that's where Rancher comes in. And when you're listening to this talk, you probably already heard about Rancher, but just as a small reminder, Rancher is a central Kubernetes management tool, which you can use to manage everything from 1 to thousands or millions of Kubernetes clusters, regardless where they're running and which Kubernetes distribution they're running. And because of that, it's a great tool to ensure consistency and consistent policies, consistent configuration across multiple Kubernetes clusters or all Kubernetes clusters in your environment. But still, with even when using Rancher, it can become quite challenging to do this if you also want to create a self-service portal or use Rancher in a self-service mode, so that maybe some development teams or some other parts of your organization can create Kubernetes on demand. If you create all these Kubernetes clusters from a central operations team, that's probably fine. You can have your configurations written down, your policies written down, and ensure it by that. But if it's more of a self-service approach where everyone can create their own clusters and manage them independently, all the different options Rancher gives you to configure Kubernetes to your liking, you probably don't want to offer to all of your developers and all of your users of Rancher. And this is just a screenshot of an RKE2 cluster provisioning screen, and you can see there's tons of things you can configure. The virtual machines that make your cluster, the Kubernetes version, networking, registries, how etcd is working, upgrade strategies, and much, much more. For a long time, to help with that and to help ensure consistency and to help ensure policies, Rancher had cluster template based on the RKE1 Kubernetes distribution. And there, with the RKE1 cluster templates, Rancher offered a very UI-driven approach. You had the same configuration options to configure your Kubernetes cluster, and in the cluster template, you could decide what is going to be the default value in the template for it. And then you could decide for every value independently if you wanted a user of this template to be able to override this value with their own choice. And it's already quite great, because you can make the Kubernetes version configurable and include inside of the cluster template as well as all the other cluster configuration options, such as container networking, backups, upgrade strategies, and all that is possible when creating a cluster. But the RKE cluster templates also had some downsides, because there you only could affect and include the configuration of the cluster, and you could not include the configuration of the nodes inside of the cluster. So how many node pools are you want to allow for a cluster, how the nodes should be configured, how the roles of nodes in the cluster should be distributed, or also you could not include things like automatic role-based access control into them easily. Also, when making some stuff and some values of these cluster templates configurable, the only choice you had was either make it configurable by the users, or then they can freely choose any value, or make it not configurable and hardcode the value. But it wasn't possible to say, hey, it is configurable, but maybe only certain values are allowed. On the other hand, you had with the cluster templates versioning mechanism already included, so you could create one version of the template, and then at some point you could create the next version 2 of the template, and then one after each other also upgrade all the clusters that use the template to the new version. So that was already in there, and it was working great. Now, we also have RKE2, the next generation Kubernetes distribution. One of the goals when developing RKE2 was to make it even easier to create Kubernetes clusters. And with RKE2, you're getting a 100% upstream Kubernetes that is CNCF certified, very easy to install, which includes zero downtime upgrades, backup and disaster recovery mechanisms, and also, of course, installable in air-gapped environments where you don't have any internet connectivity. It also contains all the necessary add-ons you need for any Kubernetes cluster, such as the container networking, an ingress controller, a metric server, and so on. And compared to RKE1, it's even faster and easier to install. It is secure by default, like all the default options are picked in a way to have a secure, consistently and highly available Kubernetes cluster. And also, it is especially hardened for security, so that the RKE distribution also now follows best practices from the FIPS standard to be also be usable in government organizations. Since the provisioning of RKE2 works fundamentally different to the provisioning of RKE1, of course, also the provisioning inside of Rancher needed to be overhauled. And to follow more industry standards, the RKE2 provisioning of clusters from within Rancher is now not something homegrown anymore, but is based on the Custer-API standard, which makes it easier to also integrate it with other systems like autoscalers that also use Custer-API definitions. Because of that, also everything when provisioning a cluster, like the complete specification of a cluster, is a Kubernetes resource. And we will see this also in the demo how this looks like. And in turn, this makes it a lot easier to automate the creation of clusters with GitOps-based approaches. So one example would be that you, with RKE2 and the RKE2 provisioning in Rancher, you could start creating Rancher with the Fleet Continuous Delivery System, create the clusters through that, and also configure the workloads in the cluster, all with GitOps-based continuous delivery. And this also creates some very exciting possibilities for cluster templates with RKE2 because we have Kubernetes resources you can interact with. And this means instead of having like a completely proprietary way to define cluster templates as you had with RKE1, with RKE2, cluster templates are in the end just Helm charts. So the same mechanism that you can use to deploy software inside of Kubernetes clusters, either third-party ones, additional features of Rancher like the monitoring, or also your own applications, you can also use to provision clusters based on templates. And this allows you to not only create clusters from it and configure the clusters inside of these templates with all the cluster configurations and Kubernetes versioning, same as RKE1. It also allows you to include the whole node pool configurations inside of such a cluster template Helm chart. It allows you to directly include cluster RBAC, role-based access controls, and it's very easy to integrate into the Rancher continuous delivery system. And the whole deployment flow and lifecycle of these cluster templates is then the same as any other Helm chart. You can put these cluster template Helm charts into a Git repository. You can version it in Git with just normal Helm chart versioning. You can then include this into Rancher through any Helm repository, or even just by adding the Git repository to Rancher. And it's very flexible to customize it then through Helm values, including not only allowing the customization of all values, you can also then have some validations on the values to ensure that only a certain subset of values are accepted for things you want to make configurable. And as I said before, it can contain more than just the cluster resources. If you have such a Helm repository and you have some cluster template Helm charts in them, the only thing you need to do is to register this Helm repository in the application catalog of the local cluster. And as soon as you do that, the Helm charts that contain cluster templates are then directly visible in the cluster creation screen to pick up on if you have the rights to do so. And for the remainder of the talk, I want to show you how this looks like. So here, let's refresh this. We have a Rancher management server running, in this case, Rancher 264. I also prepared already a Git repository, and the links to this repositories, to the examples, will also be in the slides later on the last resources slide. We'll go into a bit more detail on how this repository looks like and the Helm chart that are in there in a bit. Let me first take the repository URL here and let me add this to the local cluster where Rancher is running in. So in Rancher, I can navigate to the local cluster. I can go to the application marketplace of the local cluster and add my cluster templates repository to the local cluster's application marketplace. If you go back here to the charts, you can see there are actually no new or additional applications available in the application marketplace itself. This is because the Helm charts that are in here are specific cluster template Helm charts, and you see it a bit what they make them cluster template Helm charts. Before that, let's maybe go to the cluster management section of Rancher. And because I added this repository to my local cluster, if I create now a cluster, I not only have the possibility to create a custom cluster on an existing node or to create clusters on infrastructure or cloud providers, but I also can now create clusters with the templates that are part of my Helm repository. So you can see here is a Helm template that creates an AWS cluster, a DigitalOcean cluster, and a cluster on Equinix Metal. And these are the ones that are also available here. So let's maybe create the DigitalOcean cluster and use the template. If I click on it, first I can choose the version of the template I want to use. And in the next screen, I have a UI to configure my Helm chart. Very similar to the UI you are seeing when you install an application. So I can give the cluster a name here. I could maybe do a different one. I can pick the cloud provider credential for DigitalOcean so that Rancher can connect to the DigitalOcean API and actually create virtual machines. And in this cluster template, I also decided to make the node pools configurable. And in here, I can configure the amount of nodes I want to have and also the size from each VM. And instead of providing all the different sizing options that DigitalOcean offers, I here only have 3 available. Of course, if I wanted to do more, I also could edit this all as YAML, so I don't have to do this through an UI. I can also, of course, use this Helm chart in an automated way. And if we click Install Now, the cluster template is being installed into the local cluster. And we should see here, let's refresh this, a new cluster being provisioned at DigitalOcean. And this is running the Kubernetes version 21.9. You can see the provider is really DigitalOcean. It's going to be an RKE2 cluster. And if you can click on it, we will also see that 3 machines are currently being created and provisioned. We can go back to this cluster in a minute and look at this in more detail, and to see that it actually was created and working correctly. Before that, I want to show you a bit more, and while we're waiting for the provisioning to finish up and happen, I want to show you a bit more how this Helm charts here actually look like and what you have to do if you want to create such a cluster template Helm chart. For that, in the second tab, I opened up the same Git repository inside of an editor. You can see here is the charts directory, and inside of the charts directory, there are our 3 Helm charts. Let's have a look at the DigitalOcean Helm chart a bit. And if you are familiar with Helm charts, this should look very much the same as any other Helm charts you have seen. If not, let's just maybe go through what a Helm chart is made of. The first file any Helm chart has is a chart.yaml file. This contains the metadata of the Helm chart. And here it's specifically the name of the Helm chart, a nice description, the current version of the Helm chart, and then because this is a cluster template, it should be handled as a cluster template by Rancher. In the metadata, we also have to add 2 annotations. The catalog.kettle.io/type cluster template. This makes the Helm chart available in the cluster management screen and not inside of the app catalog inside of the cluster. And this namespace annotation that chooses the fleet namespace where the cluster should be created in. I could also make this configurable and not hard-coded like this if I wanted to. In the templates folder, you have the Kubernetes resources that are going to be created in the local cluster, in this case, when the Helm chart is going to be installed. We have a cluster resource where the name is configurable, which is the namespace is fleet default, very hard-coded. The cloud credential here is configurable, and which secret is coming from. The Kubernetes version is hard-coded again. And then I have here the complete RKE configuration, where I keep most things as default, but I set the CNI plugin here hard-coded to Calico. And I have also hard-coded one machine pool that has the control plane, etcd, and worker role, but the quantity again is configurable, and it's referencing a machine configuration at DigitalOcean. And this machine configuration is also the second file here, this node config YAML file. And this is the DigitalOcean config that is referenced here. So you can see we have the same name for it that we're referencing. And this is the configuration of the virtual machines that are created in the pool. And in this case, I want to create the virtual machines in the Frankfurt region of DigitalOcean. I want to hard-code it, in this case, to an Ubuntu 2004 image. But I'm going to make the size of the virtual machines, so how much CPU memory I'm giving them, configurable again. And for all these configuration options, these values here where there are placeholders, the default values for that are in this values YAML. So the default node pool count, how many VMs I'm going to have in the node pool, is 1. The default size, how much CPU and memory, is this 1. For cloud credentials, secret name, there is no default. I really need to pick one. And the default cluster name, as you saw also in the UI, is DO cluster. But these values here that are exposed through that are then configurable by the user. The last file that is in here is a questions YAML. And this is Rancher specific, again, to help Rancher to render a nice UI and a nice form instead of just offering a YAML editor. And with these questions YAML, I basically say for every value that is configurable, how the form field for it should be rendered. For example, I have here in the values cluster name. In the question YAML, I say for cluster.name, please do a string input field in the general group. This was the tab bar on the left side. Give this nice label and this description so that also users know what to put in there, and also make it required. Same for cloud credential, but here the type is that it's a cloud credential, so I have a drop down of the existing ones. For the node pool size, I want to not just have an input field, I actually want to have a drop down, an enum with these options. And for the count, I want to accept any kind of integer. There are much more types to also render different form elements. So it's a very powerful system. Yeah, and that's about it. I can also add more things in here, more Kubernetes resources, everything I want to add that is then also deployed inside of the local cluster, for example, for configuring role-based access control. And if we go back to Rancher, we should see that the provisioning is nearly finished and it's just waiting for the nodes to register. And maybe we can also have a look at the YAML files and YAML configurations that have been written, because they're also not hidden from the Rancher UI. So in here, we actually have the cluster resource. There are a couple more annotations and fields that are set automatically, but I can see that it's actually managed by a Helm chart. I have and here I have the Kubernetes version, I have the RKE configuration as I had configured here in my Helm chart. Everything is there. And the same thing happens if we go back to the detail page and to related resources. We can also see there is here our DigitalOcean config resource that is also related to the cluster. And if we click on that, we also see the DigitalOcean configuration for these Ubuntu machines with the 2 vCPU 4 GB RAM size was also created. So we can really see the resources in here. And this is actually also a good way when you want to go about creating these cluster templates. You can just create your cluster manually, just click it together, then look at the resources, look at the cluster resource, and look at the node configs and machine configs that are used in that. And then copy and paste these resources, remove like the metadata that you don't need and don't want to put in there. And then you just make the stuff configurable that you want to make configurable. Put this inside of a Helm chart, and you have a cluster template. And anytime you want to make a change, you can make the change, you can bump up the version, and then you can decide one after each other that you just want to upgrade the Helm chart to the newest version, which then of course will also upgrade the cluster definition and then upgrade the cluster. So if we go back here to the cluster management, we should see that our cluster is nearly done. So 2 of our 3 nodes have provisioned and joined the cluster. The last one is just waiting for Calico to start up. And yeah, let's maybe try as a last step for our demo to do what I just said. Let's maybe go to the cluster configuration and let's bump up the Kubernetes version to 1.21.10. I also then bump up the Helm chart version to 0.30. And I'm going to commit this to GitHub. So bump S version in do template. And I'm going to commit and push this. And inside of this repository, I actually have a small GitHub action workflow that takes the Helm chart, publishes them to the Helm repository that I added here. If you're interested in that, you can also later on just look at the GitHub workflow here. How is this being done? And if we just maybe check the action details and wait for this to completely finish. There it is. So we have now an updated Helm chart for our cluster template. We can actually also see this in the releases. So here's our 0.30 release for our Helm chart. This is the packaged tar file for the whole Helm chart in here. And if we now, let's maybe go into the local cluster to just force this, and let's go into the repositories and let's force a refresh of this template. Otherwise it will refresh maybe every minute or every 2 minutes. I don't want to wait for this. So here we can just trigger a refresh, so it really refreshes it. And one way to upgrade it would be to go to the installed apps, and you can see here it's actually an app that is installed, and also we can upgrade it from here to something did not work yet. Let's check again if maybe the refresh hasn't run through yet. Now it's done. So here I have now also a reminder that I have a new version for this DigitalOcean cluster template. So this is one way to go about this. And from here I can also directly say, okay, I want to upgrade it now to the 0.3.0 version. I keep all the other stuff the same because I just want to have the newest template or the newest template applied. I click upgrade. The Helm chart is upgraded. The new cluster configuration is patched here. And we can also see now in the cluster management view that we have now a new Kubernetes version referenced here. And now one by one, my nodes inside of a cluster upgraded. And of course, you cannot do this with everything else, not only with the Kubernetes version, you can also add more nodes to it or change any other thing inside of the template. And yeah, this is a very powerful tool to make it easier to keep the configuration of your clusters consistent even in a self-service environment. If you want to know more about cluster templates, there is of course documentation about this in the Rancher docs. Here is also a link to the repository that you just saw that I used in my demo. And also in the Rancher GitHub organization, we have a repository with more cluster template examples, also for different cloud providers in different configurations. And with that, I hope I could get you interested in trying out RKE cluster templates. And I hope that you will enjoy the rest of SUSECON. Thank you and bye-bye.